Hello, everyone, and welcome. Thank you all for joining us today for automating our infrastructure with code. My name is Firas, and I'm the event planner for the Reactor in Redmond. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary. Remain professional and on topic. This session is recorded. It will be available through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link to that in the chat. I'll also be sharing some links to the Reactor Meetup page and monthly newsletter. If you are interested in checking out what other sessions we have coming up, I'll also share the check-in link for that. Which brings us back to our event today. Our speaker is Sam Ronsky. He's a regional cloud advocate at Microsoft. And Sam, welcome, and we look forward to hearing your event now. And I'll pass this on to you.
Awesome. Thank you so much. Hello, I'm Sam. Thank you for the introduction. I am going to be taking another look, kind of extending what we've been building on this month for our .NET application. Today is going to be a little bit different. We're doing what I'm calling a spike. Some people might call this different things, but we're going to be exploring infrastructure as code today. What infrastructure as code is the idea of replacing your infrastructure with code. So if we look at what we have done with our current resources, we've gone to the Azure portal, if I can find it in all the tabs that I opened for some reason, and we've created resources here. We've clicked buttons and created new resources. This is useful. It gives us a really easy way to go and create those resources. But the problem with this is it's really hard to actually understand what's happening or what changes are being made or what the current state is. What infrastructure as code does is provide a declarative way for you to define your infrastructure. It means you can say, this is what the infrastructure should be, and tell Azure or whatever service you're using, whether that's Terraform or Pulumi or something else, to align your infrastructure with the declared state. What this is going to do is kind of create your infrastructure for you and set up all of these resources so you can have something defined somewhere that is saying what should exist. What we're going to be doing is a spike. I kind of briefly talked about that. It's sort of a planning thing. This is what we're doing here is kind of exploring some new topics to me. And so to do that, we're introducing what's called a spike. So some people might call it different things, but what that does is give you a way to provide a time-boxed piece of time to focus on learning or exploring a new concept. In this case, we're going to spend 2 hours exploring different ways we can solve this infrastructure as code problem so we can actually have a declared state for our infrastructure. Right now, we just have a relatively simple state. It has a resource group, and that resource group has a service bus with one queue in it. And so that's sort of what we're going to be trying to recreate. What this is going to do is give us a way to explore that while time boxing it. So if you run into a cliff or start spending a bunch of time, you're not constantly using that time. It sort of is a way to explore things without spending so much time that it prevents you from actually accomplishing what you need. Our application already works, but what we want is some way where we can declare that and ideally get that into Git. So we have a definition in our GitHub project repo that's saying, this is what the infrastructure is. What that means is that now, whenever we want to change anything about our infrastructure, it's just another pull request. All we have to do is just open a pull request to change the infrastructure. We don't need to navigate to the console and change things. Instead, it's just the same exact process that we were using for all of our other code, just for our infrastructure as well. This makes it really nice for seeing who changed things and when things were changed. It also means you don't have to give all of your engineers access to create and destroy resources in your entire application, which can be a very useful thing. It also makes your infrastructure fairly auditable, so you can actually go and look at that. To talk a little bit about what's actually happening here, Azure uses ARM behind the scenes. And we're going to be talking a lot about ARMs today because that's just the nature of things. But ARM, or the Azure Resource Manager, is a definition of what resources exist for your thing. So if we look at our matrix mesh resource group right here, we can actually go and look at what that ARM template is that defines the resources we've created. You can do this for any resource you've created. Just go to export template here and you will get it. You can also do this through the CLI. We're just going to explore this, so this will work. If you're curious, I think we can just do that from the CLI with something. Group export, and then I'm just exporting matrix mesh, which is our resource group, to a file. So piping this over to myinfra.json. And that's actually going to create a file with everything in this resource group for us. Some errors occurred. Okay. We'll take a look at those in just a bit. But this is our infrastructure. This is what exists in that resource group and sort of what we're interacting with. As you can see, it's somewhat long. That's sort of the difficult part with ARM, is it describes your infrastructure, and your infrastructure is pretty complicated. We don't have that many things going on here, but there's a lot defined here. Bicep, which is what we're going to be exploring, is going to make it a little bit easier for us to actually dive into this and actually see what is going on. So what Bicep is a programming language that allows you to dive into your infrastructure and code for your infrastructure. Hello, iTech code, appropriate name. So what we're doing is we're creating this thing and providing code for it. We're going to be kind of walking through the Bicep tutorials, which are out on the GitHub. It should be shared in the chat if you want to check that out. It's at github.com/azure/bicep. So the project is open source, and it gives you a way to sort of work with your infrastructure. I'm typically going to be trying to look just at Bicep today. If we have some time, we'll also look at Pulumi, which gives you a way to automate your infrastructure and do very similar things in a programming language of your choice, whether that's TypeScript or C# or something else. It provides similar resources here. There's a number of different solutions in this space. This is not the only one, and it's not the one that you necessarily need to use, but it is a really cool tool, and it gives you a way to control stuff without having to manually go and change it, because that's just really hard to track. And if you've ever inherited resources or infrastructure, one of the problems is figuring out who wrote that thing and why does it exist like that? Or if you've ever set up your own personal computer, for example, you've done a whole bunch of things. You've installed a whole bunch of custom things. And if you need to, say, reinstall your operating system and lose all of that configuration, you want something that can get you back to a running state as quickly as possible. That's ideally what an infrastructure as code system is going to do. It's going to give you a way to automatically scale up and create infrastructure for you and go from there. I've talked too much about this, so we're just going to jump right into it and start playing with this. We're going to kind of start from scratch here and sort of build up our infrastructure. I think that's the easiest way. There are ways to import both of your resources. The commands we're going to be looking at are az-bicep. So az-bicep, and then we can just type help, and that's not how you type that. But az-bicep help is going to give you some help on what is supported. If you do not have az-bicep in your Azure CLI, you may need to upgrade the version of your Azure CLI just to get these. Otherwise, you can install the CLI tool directly, which just lets you run bicep and all of the commands I'm going to be using. There's a few things that we get here. We get build, which lets us build a bicep file. Like I described, ARM, or the Azure Resource Manager, is going to describe everything as JSON in resource format. Build is going to build into that format for you. Bicep is not a ARM replacement. It is an abstraction layer. It's built on top of it to kind of give you all of that extra goodness and hopefully remove a lot of the extra work that goes into the maintaining and working with those large JSON files. It also gives you some nice programming features. You can do loops. You can do variables, things like that. The other nice thing is decompile. So we had that Azure JSON file, the ARM template. We can actually decompile that into a bicep file and then use that as our way of creating that, which means you should just be able to export your ARM template and use bicep decompile to get something that you can use to build all this stuff. A few of these other things we'll probably explore. Honestly, still learning. So that's sort of the point of this entire thing, is to kind of learn this together, figure out how to do some infrastructure as code stuff, and hopefully get something set up so we can actually deploy part of our infrastructure using these tools by the end of this stream. So yeah, that's sort of what we're going to be poking at. So let's actually start. The fastest way to start, first off, before I get too far ahead of myself, you're going to want, if you're kind of following along, you're going to want some of the bicep stuff. So there should be a link that was posted in chat that has aka.ms/bicep documentation. That's going to send you here. And from there, you can actually click this create bicep files thing. So this link is going to allow you to figure out how to create bicep files. The thing we want, or you're going to want, is this bicep extension for Visual Studio Code. You can also just search this through Visual Studio Code and find the bicep extension. What that's going to do is give you a way to automatically create or get IntelliSense for the bicep files that you're creating. So you can actually walk through this and get some help about what's supposed to happen, and hopefully avoid some errors and get some nice pointers while you're learning this. We're going to be learning from the GitHub because there's actually some really nice tutorials from there. There's even one for creating a service bus account and working from that. So again, this is almost the first time I've touched this tool. So we're exploring. I have worked with infrastructure as code before. So that we're sort of relying on that and sort of building on that and hopefully learning together and figuring out what to do with this. So here is the first example. The way this works, the way bicep works, is you give it a bicep file. That's going to be main.bicep in this case. And then you deploy it. And that's it. That's really all there is to it. So in this case, the main bicep file has everything we need. It's just finding two things, a parameter and a variable. So hello world, and there we go. We can just copy this. If you want, you might just want to clone this repo. So let's actually just do that. There's no reason we couldn't. So I'm actually going to fork this over into my own repo. What this will allow me to do is actually make changes and potentially commit them to my repo without having to worry about influencing that other project, because I don't have access to push directly to that project. So now that it's in my repo, I can just go and clone it. So we're just going to copy our URL there. And let's go and create something. So if we go in here, let's just pop out of that matrix mesh so we don't start creating like submodules. That's a little bit more than we want. So let's just git clone and clone bicep. And then once this is done, we should be able to actually copy this and actually start working with this. So that's going to copy everything down. And then we can actually do code-n to create a new project. So code-n, and we want bicep. What this is going to do is open a new version of Visual Studio Code in that directory for us. So bicep is the directory. And so if you're not familiar, that's actually a really handy shorthand. -n will open a new version of Visual Studio Code. -r will reuse the current window. So if you're in Visual Studio Code like I am here and just ran it with -r, that would reopen it in the same window and you could just start working with it that way. It can be kind of helpful if you want to focus in your project on a specific like sub-project or something like that. But let's explore this. Here we go. And this is like the whole thing. So there's a bit here, but let's actually just dive a little bit deeper into this. Let's go into the docs and docs examples. And I believe it's there, 000. So the very intro stuff. So we can also just open that here we probably don't need this whole thing open, but it's there. So hello world is what we're looking at. So let's navigate into that. O1 hello world. And then we can actually look at what's in this bicep file. So here is a bunch of things. We're not defining any resources. What's going on is we have a parameter, which is your name. So whatever I want to say, and then variable, which is just some variable here defined. So hello world, hi. And we're just going to output some new string here. So again, basic introduction stuff. What this is doing is giving us a way to input information using parameters and output information using outputs. And so that's useful if you want to like output information about resources you created, or input information about like what region you want to create these resources in. Things like that can be provided using exactly the same syntax. So we're going to just compile this. I believe it's AZ bicep build, and you need a file, which is main bicep. That should build this for us. In hindsight, I should have removed the main.json, but it's there now. And so we get this with an output somewhere, hopefully. Loading ARM. Okay, cool. What happened here? So we built this thing. This created the ARM template for what we're actually doing, but it did not export it. It didn't deploy it, is I think the best name for that. So instead, we're actually just going to do that here. So let's actually create a new resource group and deploy our fancy little new tutorial thing. So if we can get rid of this, that would be great. Or not. Okay, cool. Let's just split that and it'll be a little bit easier to, not really. Does this work? Oh, okay. So we have our Windows terminal here. Let's actually just get to the same place. So development advocacy, bicep, docs, examples. A little roundabout, but let's make this a little bigger so all of you can see it and explore this. So we have this new thing. Let's put this over here. And we want AZ deployment group create. So we're going to create a new deployment group in some resource group. We need a resource group. So let's create that. AZ group, I believe it's create. Find out. If you're unfamiliar with what to do, just -- help. It's great. Unless you're in Go and then it's Go help whatever. It will help you out. But anyway, we're going to create a new group just to kind of poke around at this, create. And this will be sort of our test environment. Ideally, we don't want to be playing around in our theoretical production environment or something that other people are going to be using. We want something just for us to tinker in. So we're going to call this just our dev test, I guess. So let's put this in the Western US. I'm an advocate for San Francisco, so that's where we're going to be working. And let's name it something. What am I doing? There we go. That goes here. Dev test. Cool. So this will create a new resource group for us. Great. And now we can actually start doing things here. So the command we want is to actually deploy a template file, which can be either an ARM template or a bicep template. Either one will work. And we're going to just provide that bicep that we provided. So we should do AZ deployment group, create resource group, give it the same name of our resource group. So we'll just do dev test and give it the template file. And that is inside of this hello world. So it's O1 hello world. And it's called main.bicep. Here we go. And so if we run this, hopefully we're going to see our thing get created. We do need to provide our parameters that we asked for. So I'm just going to say, hello, Sam. And then we should see an output here after this gets built and deployed. It can take a little bit because we're actually interacting with Azure at this point. we're deploying this thing out to that new resource group. There's nothing really there. But what we should be doing is getting something back. Again, this is getting us the introduction to some of those primitive things that the basic types that you need, the parameters, the variables, and the output structure. So you can put things in, define things, and get things back out. And what do we get back? We get an output here of hello world, which sends a value of hello world, hi Sam. And that is defined inside of this. So hello world is coming from here, I believe. And then that's actually just coming back in this terminal. So we have hello world from our output with the value. It's a string type. We define string, and it comes back with the string. So that gives us a way to kind of interact with Azure and get resources back. You can also see what parameters were provided, things like that. Anyway, that's one. This is as far as I've gone. So we're going to see what we learn next. But basically, we're just going to be kind of stepping through this and learning different things we can do to actually define all of this stuff. What I'm kind of looking for, okay, there's a bunch of string functions. We can skip over some of this just because we have a target goal of being able to deploy our service bus to this new resource group. That's what we're aiming for. All of this other stuff is great, but that's sort of what we're trying to learn and figure out how to do. And so that's sort of what we're working around and trying to coordinate for. So these are great. These are teaching you different ways you can work with strings, but we don't necessarily need them for our project. So we can skip over them, multi-line strings, arrays, and JSON objects. So arrays might be useful. How do those work? Okay. So I'd mentioned you can define specific regions that things might be defined in. This is happening here. In this case, there is a parameter for the Azure region that we're going to deploy to. It's a string. But what's happened is there's actually an at allowed restriction that's actually going to limit what can be used as that parameter. So instead of being able to input any string that isn't valid, instead there's only a specific number of those strings that you can provide. That's what we're doing in this, is limiting those. And then doing the same thing here, region timecodes, and then outputting them. So finding what the region is and getting the timecode for it. So that could be useful to explore. Mostly curious, what happens if I input something that's wrong? Like something that shouldn't work. So let's open this. And we can just deploy something. This will also give us an idea of if anything happens, if we get any warnings or anything when we deploy this. One of the, I had mentioned going and configuring things in the console. What that can introduce is called drift, when your infrastructure drifts from the original definition. And that can still happen here, but this should correct it, is the idea. This template, these ARM templates or bicep definitions that we're using to create the ARM templates, they're intended to prevent your infrastructure from drifting away. You might end up finding that, oh, we actually need this thing added on, or we SSH'd in and ran this shell script or something to change some random path variable, and now our code works. This prevents that from happening. Not necessarily prevents you from doing it, but what it does prevent is when you recreate your infrastructure, it can correct some of those. And remove some of that like custom configuration that somebody did as like a quick fix or something. This prevents that from happening and instead forces you to define what the actual state is that's required to run your code in some declared way. So people can actually analyze it and understand how your stuff runs. Because resources get complicated. And we're already getting like big files, even though we've only run a few different resources. So that's sort of what we're working with. So let's create this and see what happens. We should get a list of parameters. This is cool. It gives us an actual list. So we can actually, looks like the default would be East US if we did this. So let's see what the time zone is in the East US. I didn't input anything, so we should just get East US as the time zone and then get an output out of that. Also, this is intended as somewhat of a co-learning thing. If there's other questions or you've used some of these things and you have questions, feel free to let me know. I'm definitely looking to like go on those tangents and explore those things and figure them out together. That's sort of what we're here for. So yeah. But anyway, this is going to run and we're going to get our parameters and a time zone of the Eastern Standard Time. Okay. What happened here? So we pulled out, in this case, East US was our allowed parameter. We provided East US. And then we looked into region to time zone, which is a variable containing a bunch of keys. It looks like a dictionary is effectively what this is. And then we're indexing into that dictionary of different time zones using the AZ region. And so that's what we're getting back out. And we get the region and the time zone we selected back out. So that's how this is working. We're just working with arrays and lookup table or dictionary or something. So our array is the next thing. We already did that. So important thing, loops. It's a programming language, so you can do loops over all the different types. In this case, we have for I in bicep variable, element I. I wonder if that is an int or the type. That's a good question. I guess we'll find out. So I don't actually know. Coming from a C# background, I somewhat expect this to be the actual types. So Michael, Dwight, Jim, and Pam. But it could also just be the integer index of those elements in the array. Looks like it's going to be the actual item. But there we go. And then here we get the name and I, which I believe is actually going to be the index as the second item there. So similar, I think, to Go in how these things work. I get languages confused, so we'll see. But this could actually be something useful to know. So let's just run that and see what happens. And basically, that's what we're doing. We're picking these things up by just running them because we can. So in this case, this is example 20. So that's not the name of it. And we want 2020. Typing the wrong things. Loop. There we go. That's going to go and create this fun new file for us. So we get this to go and run and create some cool new stuff. And hopefully we're going to get out something. What do we expect out of this? In this case, it looks like we're directly outputting different elements. So the output types, there should be 3 different outputs, it looks like. Different names. Okay, so it looks like we should actually get the same thing 3 times, if I am understanding this correctly. Because the first time we're just going to get the element, the next time we're just getting the element, and then the third time we're getting the index, but we're indexing into the array. So we should get the same thing again. So I think that's what I expect to see. Is there anything else going on here? No, I think that's it. All right, cool. So that's sort of what we should see. Let's see what we actually got. Yes. Michael, Dwight, Jim, Pam, and the same thing 3 times. So 3 different ways to sort of work with arrays and loop over different parameter lists. Anyway, next thing, what's this? JSON stuff. JSON object. I didn't mean to click that. Let's get rid of this. What did I click? 1 second. I got confused by doing something bad. So a multi-line string example, cool. JSON object, what is this demonstrating? A simple JSON objects. Okay. So this gives us a way to actually deploy JSON objects. So let's actually take a look. Love the terminal background. Thank you. If you're unfamiliar This is actually a cool little tip. You can actually, this is a shader that I actually made. So you can actually apply shaders to your terminal. If you want to learn more about that, there's a bunch of videos on it, but it's an experimental feature in the Windows terminal. And you can just go and create your own shader for it, which is literally just math. And then you'll get something like that. So it's pretty cool. If you like shaders or you want to learn like graphics programming, it's actually a really fun like way to explore it. But there you go. You can do animated, cool shader stuff in your terminal. Sort of tangential to what we're talking about, but super cool. So anyway, in this case, we're doing JSON strings. So we have, looks like double quotes or triple quotes rather. One thing I would call out, I'm learning a lot just from going through these examples, but I'm doing more than just running them because we're actually picking up things that aren't explicitly in these tutorials by kind of looking at the code and seeing different things. I'm actually really liking these because they're actually exposing you to those different new things in multiple ways. So in this case, multi-line strings, triple quotes gives you a multi-line string. That's good to know. That's something that we're probably going to want to be able to do. So there we go. We can create multi-line strings if you want to embed a JSON object into your code. In this case, it looks like a JSON array, or you can do it in line like that. So JSON array 1 is that one, and JSON array 2 is the inline one. And then 2 outputs, just iterating over those. Oh, that's cool. Okay, so there's a special function, it looks like, called JSON that's going to parse JSON for you. So what that should do is go through here and pull all this stuff out. When I'm curious, while we're here, let's poke at this a little bit more and actually figure out if we can do some other things. So let's create the multi-line string, and we're kind of at that point where we can actually start kind of and do some cool things. There are some really cool, as far as the terminal shader stuff, there are some really cool ones like retro terminal shaders that will do like scan lines over it and stuff that already exist. Scott Hanselman has done has a blog post that kind of introduced me to them and kind of inspired me to write this one. So definitely go and like search them. They're pretty cool. Anyway, getting distracted because graphics is cool. JSON string 3, we're just going to define a JSON object here and see what we can do. So if I can remember JSON, there we go. Let's call this name. And we're just going to do, why not? So we defined a really, really basic JSON object. And now we can actually go and work with that. Let's put it here. So JSON string 3. And there we go. So JSON string 3, you get JSON array 3. And then here you can do this. And let's actually output something. So output works like that. And then we get JSON array 2. And we can do that. JSON array 3 is going to be an output of the string. What we're doing here is just testing if this will work as a way to output that. So JSON array 3. And there we go. Let's access this. I believe name. And it looks like it already knows what the name of that is. So it already has parsed all of this. So there we go. We get JSON array 3. Output type is JSON array 3. That's confusing. Let's maybe out. Kind of inventing my own naming as I go through this, just to kind of make this clear. But if I understood this entirely correctly, and I haven't even run this yet, but if I understood this correctly, this should give us the name out of this. So let's see what happened here. All right, terminal's being weird, but that's okay. Let's do this 30 and JSON object something. JSON object. And we call this simple, dash simple. All right, cool. Got main.bicep. This should give us those 3 outputs that we expected, and we should get something back. Yes, this is not C#. This is a custom programming language. It's called Bicep, and it is intended for managing resources. There's a lot of different ways you can do this. The reason I chose Bicep is because it's actually explicitly written for managing resources. So you don't get all of the stuff that you might expect in another language. If you want that, consider Pulumi. But there's a whole bunch of different options that you have here as far as what you can do. I would say yes. I'm not as familiar with Terraform as other things. But yes, this is in the same realm as Terraform would be. Yes, Bicep is Azure specific. I believe it's based around ARM, the Azure Resource Manager. So I don't expect that it would work other places, and I'm not aware of anything like that. But again, I'm learning it, so there you go. If you want something that is cross-platform, Terraform is actually a pretty good option for that, or Pulumi, which is similar. Those give you a way to kind of do some of that stuff. But each cloud provider is also going to have different ways of defining anything. In Azure, ARM or the Azure Resource Manager is your way of defining resources. And so what Terraform and other things are doing is translating from some generalized code into each of those different resources, depending on where you're deploying. That's what those are doing. So we ran this. So let's actually look at what we got. We got our output string of Sam. So that worked. That's cool. And we get these two arrays. So we can actually index into just JSON blobs. That's cool. That means that we can actually like include other JSON stuff. Don't know if it supports YAML. We'll see. But we don't need that, so we might skip over it. Again, the point of this is we're doing something similar to a spike. So we've set aside 2 hours to dive into this and try to find a solution that we could use in our application. If you're doing this in your own teams, it doesn't have to be 2 hours. It doesn't have to be anything specific like that. But you should time box it. Time box what you're investing in and how long you're going to actually spend looking at that. Because otherwise you might spend all this time and not really, because you don't have a deadline, you might not actually find anything. There might not be a deliverable, because the deliverable of this is action items for the future. I don't know if I made that clear earlier, but that's sort of what the goal of this is. You might get something that you can immediately use out of a spike, but that isn't always the goal. A lot of the time it is, we have this problem we need to solve. In our case, our problem is that we do not have a way to know what is in our infrastructure without going and exploring the Azure portal and downloading ARM stuff. And even then, we don't know when things changed or who changed them. And so that's the problem we're trying to figure out a solution for. And we're exploring Bicep as a way to do that. So anyway, yeah. What's going on here? More complex JSON stuff. It's doing what I was already doing. Cool. So I jumped ahead. Perfect. So we've done that, and we've graduated from the entry level stuff. So all of that is done. So let's jump back here and go into the 101 stuff. And this is where we should hopefully start seeing some actual resources be deployed. So far, we've been kind of looking at inputs and outputs. Now we're actually going to take those building blocks that we've been learning, figure out how to create resources with them. So let's take a look at that. We probably don't need all of these because there's a lot. There's a bunch of different options here for like things you can create. I've really enjoyed kind of looking through these, but we'll probably pick one or two and then go from there. We could spin up some AKS instance. That'd be interesting. Let's actually try that. I'm curious if this might be too big, but I'm curious how. Okay, this might be a little bit more than I want. I want something ideally that is like concise, because a lot of these can be. So that's sort of what we're looking for. Azure container instances with a Linux container. How's that look? A lot of these are also parameterized, but also you can use these examples as a leaping point for what you want. And while we're here, we might just skip over the 101 stuff and just do the 201 stuff that actually introduces Service Bus, which is what we're trying to get to in the first place. So we'll see. We could create a Redis cache or web app Linux. How's this? Oh, this is nice. This is tiny. So let's work with this. So we're just going to create this web app Linux and go from there. So this looks like it's creating a app service plan on a Linux VM and then deploying some site to it of the kind app. Admittedly, I am not very familiar with Azure Service Plans stuff or this in this stack in general. Not really something that I've played with. But we should be able to deploy this and actually see something. There's a bunch of things defined here. Looks like it's a PHP app. Okay, that's cool. And then we have the resource group locations. What this is doing is grabbing from our resource group. Let's get the location from that and use that as our location. The other thing is using a SKU, so figuring out what to actually define the image as, what that VM should use as its SKU. And the web app name looks like it's just creating some unique thing. And yeah, we should be good. You can see how the variables are used in this code. In this case, we have SKU defined with a name of SKU. That's a reference to this one. So I don't know if we'll see it, but it is referencing that it's a link to the SKU parameter. And this is, I think, maybe a good use of our time to actually create this. We'll see, I guess. Website with container might be cool, because that's sort of more in my wheelhouse of understanding this kind of stuff. What's this doing? Creating a container registry, setting up an admin user, and deploying a new website with our Docker image, and doing a bunch of the same stuff. So this is sort of an expansion on what we were just doing. It looks like this is just doing it with Docker. So creates a container registry. That's all this is doing. So in 4 lines, we've defined a container registry we want to create, which could be cool. I think we should also be able to do, does this support SKU? I can double check. Because we're creating the container registries, and so we should just be able to kind of iterate on that. I believe the SKU name basic. Does that work? Can't be using the existing thing. Okay, cool. Might help if I do this. Name basic. Still might not like this, but we'll see. I expected a new line character at this location. Commas are not used as separators. Okay. That's a difference. I was kind of taking some inspiration from JSON there. There are no commas at the end of these lines, like you might find in a JSON file, for example. So instead, you just do this to define the thing. One thing that might be useful is figuring out actually how to actually learn where this stuff is defined. I skipped over a whole bunch because I've done this before, but there's a lot that got introduced in this whole thing. So let's take a quick look at what is actually happening here. Like I said, I don't want too many people to get lost, because that was a big jump. We kind of skipped from how do I create a variable to awesome, let's create a container registry and a website and other stuff with configuration. Maybe a bit much. So what's going on here is we have the resource. So we're defining we want a new resource. Same syntax as we want a new parameter or something like that. The next thing is the name. So that's a shorthand name inside this definition that you can use to reference this later on. So we have a resource called the container registry, and we're just going to create that container registry. What's going on here is the version from ARM. So ARM has a bunch of different API versions. This gives you a way to specify which version you're actually talking about. So it actually knows. I don't know what this existing means. So we might have to explore that, but we'll see. Is there just a container registry example, or we can create one? Container registry. That'll be a lot simpler. Cool. So what we're doing is creating our container registry with an admin user. It looks like with the SKU Okay, weird. It is the same thing. So skew there. And what's going on here? We have a few different parameters. You can actually specify what this thing should have limited on it. So in this case, it has the ACR name, the Azure Container Registry name, has a min and max length. It also has a description of what we're deploying, and enable admin user. That's disabled by default. Location for all resources. We're grabbing the same resource location from our resource group. And then we have that array allowed again, which is saying there are 3 different tiers for your container registry. This gives you a way to choose them. Basic is going to be probably the best choice for trying this stuff out. And then we get all of this stuff. So here's our container registry. It's using this again, this time the preview API. And then we get tags. So we're going to call this container registry and give it the name there, skew. We're going to pull that from our parameter again, and the admin user enabled is on or off from the parameter again. And then the output is the login server that we're going to log in at. So this should be something.acr.io, I believe. I should know that, but I don't. So let's run it, see what happens. We should get something back useful this time. So we should actually see resources get created from this. So let's do AZ. We have it up here. We're in the 101s. We need to go up actually to do this. So we're in our group. Let's create that. This one might also take a little bit of time, because we're actually deploying a container registry. We're actually spinning up resources with this command. So same thing with a normal create resource thing. This is going to do that again. So in this case, we're going to do this and run, go up a directory, go into 201. And we want container registry with main.bicep. We should just be able to run this, and we'll get asked for a few properties or parameters. Or I'll mistype something. What'd I do? I was in the right directory to begin with. Whoops. All right, so let's just, there. There we go. So this will actually get us a way to create that container registry. Please provide a name. Sam's Cool Containers. Because alliteration is cool. So there we go. This should actually start creating this for us. It should also be using some of those default parameters that we provided. So what I'm judging from this, what I'm learning from this, is if there is a equals something, it's going to be the default value. So that's what, if it isn't provided, it's effectively creating an optional parameter for us. Because we did not get asked, should we create an admin user? We didn't get asked what the location should be, and we didn't get asked what level we wanted. It's just using the basic, the defaults. So that's kind of nice to know. And then this all should be getting created for us. So we should be getting something, at least one resource, list operations for details, please see deploy operations for use. Wrong container name. Okay. So our types are fine, but I think I gave it spaces, and maybe that was bad. Or I gave it thing. So let's do Sam's Cool Containers without any of the dashes. But I think it's just the alphanumeric characters. And dashes are not alphanumeric. They are symbols. All right, cool. So this will actually deploy this for us. We should get a container registry eventually, or we'll get another error that I can figure out. But this is sort of the next step in creating these resources. So we're actually moving pretty quickly here. The next thing that I'll kind of want to take a look at before kind of wrapping up and getting this to something that we can actually start implementing and using is we are going to take a look at the service bus one, because there's actually a service bus example here. I haven't used it yet, but I found it. So This is a definition for Azure Service Bus that gives us a few different parameters. We have the namespace. So when you create an Azure Service Bus, that's the namespace. And then when you create queues and add queues to that, those are queues. So this is going to create a namespace with one queue in it, which is exactly what we're doing already. That's what we're creating. So this is basically going to create that same resource structure for us, but it's going to do it programmatically. We're actually going to be defining and declaring what our resources should be instead of just making things. So hopefully creating something reproducible that we can keep using over and over and also kind of monitor. And then we get a bunch of extra parameters here for the service bus. I do need to look up what some of these are, like lock duration and message time to live. Some of those are things that I'm not entirely sure what these symbols mean. Again, also learning service bus. Sort of the goal of this entire project is let's learn together. So we're kind of trying to walk through this and learn different things together. Maybe this is done. It has. All right. So we now have completed this. We should get something back out. You can see our parameters there and our outputs. We have a new container registry called samscoolcontainers.azure.cr.io. And if we go and look at our portal, that's not the right thing. If we go and look at our portal, under here somewhere, I have too many tabs. We go here and go and refresh this. We should see a new resource group that we created, and we should see the new service bus or new container registry. So we have matrix mesh here. And then that's not the right thing. 1 second. I'm a little lost. There we go. Dev test. There we go. All right, cool. And then we get our SAM school containers here. So this is our resource that we created. We defined it all in Bicep. And now we're able to actually create this and work with this and manipulate it. The other thing we probably want to see is like, what is the difference when we create these things? So we created a container registry. That's neat. I want to scale this up. So we go back to our container registry. Where is that? Again, I'm mostly just focusing on using the same things, just to kind of walk through my learning process. I tinker a lot with things. That's sort of how I learn. You can do different things. Let's figure out how to provide a different size. So instead of providing standard or instead of using the default basic, let's provide a custom SKU and say we want to use standard. So let's do that. Jump over here and figure out how to do that. Can we just append help? Yes, cool. So AZ deployment create, group create, something. What I'm looking for are two things. One is this what if. What that's going to do is say, if I ran this command, what would happen? So we should see the changes that we're expecting. This can be really useful in like PRs, for example. You can run a what if on a PR to see what would the effects be without actually running the thing, so that reviewers can actually see a little bit better what's supposed to happen with this change, and make that call that way without having to like merge it and try to deploy it and see what happens, because that just makes things a little bit weird. Proceed if no change. Cool. Mode. How do I provide a parameter? Not entirely sure. Parameter is P. All right, cool. And it looks like it's similar to like Docker or other things. So it's a key value pair. So we should be able to just look at this. And let's do -P. Now it's ACR SKU equals standard. That's the parameter we want to set. And I want to run -what if. And so this should actually tell me what happens if I change the SKU to standard. What's that going to do? And we should see something. Sam's cool containers. We do want to keep that the same. It also means by providing these parameters, we can avoid having to type out that same thing over and over again. But hopefully, if this does what I think it should do, we're going to get some information about what changed. Again, learning this, so we'll see. But in this case, we see a few different things that get changed. We changed basic to standard, and it looks like a few other things are going to change as a result of that. We're deleting data endpoint enabled false, and encryption disabled is also getting deleted. It looks like there's a key up here for deleted and modified, so you get color-coded information about what's deleted versus modified. We're modifying our SKU's name to be standard. You can see 1 resource changes, or resource changes 1 to modify, which means we're going to modify this thing and get something new. So what happens if we delete this? So let's just get rid of everything. What does this do? So if we remove everything, I would expect this to clean it up. We can get rid of that parameter and just run this. And I think this should just get rid of our resources. Otherwise, we're going to have like tailing things if we forget our resources. There were a few mentions of Terraform as well. This is probably a good thing to point out. Unlike Terraform, Bicep doesn't have state files. There's nothing else being created. 1 resource to ignore. So it doesn't look like it drops your resources. It looks like it says nothing here. That could be useful. I'm curious how you would delete them. Maybe that's a little bit outside of what we need to do right now, but that could be something that's useful to know. But again, state files are using Terraform to kind of track the state of your infrastructure over time. They can get a little complicated though if you have multiple people working with them. This doesn't have that. It's compiling into ARM, and then that's the state. That's the expected state that you're going to end up with. So that's what's going on here. That's why we're not getting like temporary files generated when I run these. Nothing's getting generated when I run these. If we build them, we'll get a new main.json. But otherwise, we're just passing Bison or Bicep. But anyway, tech names are hard. We're passing that Bicep file to Azure. It's creating this thing and giving us all these new resources back, and we get all of this. That's pretty much what's happening. It's probably good that it doesn't delete them, because then if you like accidentally delete something and then push that change for whatever, you just dropped your database. Maybe that's not a good thing. So I don't know. I think that's probably a good idea to do this. But again, I'm sure there's a way to delete things. Let's figure out how to break things. So in this case, roll back on error, on no change mode, complete. So incremental, I think, is going to actually override things or build on top of what's there. Complete, I think. So we want dash mode equals complete. Complete. What does this do? I think this is going to actually cause it to get deleted if I'm aware of what's going on there. Could be wrong, not sure. But again, another one of the useful things with all of this is something called GitOps, which is as confusing of a name as DevOps, maybe even more so. But it's the idea of actually storing your infrastructure in Git, so you can track those changes in Git. Basically, once that gets executed, you actually have an entire Git repo that stores your infrastructure state and your code all together, and you can manage all of that at once. So now we're getting a delete because we switched over to the complete mode. So instead of incrementally building on top of what's already there, this is overriding that and would delete it. That's good to know. I imagine incremental would be focused more on modifications and changes. This will like wipe out state. So, okay, cool. That's good to know. Now let's actually start doing other things. We had talked about service bus, so let's do that. Also, let's commit this. I don't need a container registry in this repo, so we'll just drop it. So I should just be able to remove the what if, and it should just automatically commit it. We may need to provide a name here. Or not. It should, I guess it's just running. Where is it getting? Oh, there's no name. That's why it's not asking for a name. this is the file we're deploying. There's nothing there. Okay, that makes a lot more sense. Cool. All right, so that gets rid of the entire thing. That should wipe out all the state there. We should see that get propagated out over here. So this resource group should have this disappear eventually. I don't know if we'll see it right now, but there we go. And so it's gone. And now our container is gone. And so now we're kind of managing all of the instances or stuff that's going on in Azure by manipulating this bison or bicep. I'm going to keep confusing bison and bicep. The different tech. Anyway, so we end up here. Let's jump all the way over to the 201 stuff and look at service bus. Some of these settings, I'm not entirely sure what they are. I need to figure out what those are because I just don't know. It looks like some sort of timestamp thing, but I'm not sure what the characters in there mean. What does DT and H? Not sure. Anyway, that's there. It looks like it's something. That isn't helpful. Anyway, here's our service bus. This is going to create a service bus with a namespace and a queue. The first thing is the namespace, which is relatively short. It's going to define the SKU for the service bus that we're creating. And then where it's going to be located, we're just pulling that out of the resource group. And then everything else is happening here. One thing that you might see if you work with, actually, we can just look at the ARM template because it's already in the repo. If you look through this, there is a depends on somewhere in here. Depends on resource type. That isn't in Bicep. What's happening is Bicep is inferring these dependencies by looking at what's referred to in the language. So if you're referencing a resource that is higher up in the infrastructure, it's going to wait for that and create a dependency on it. So it actually exists when you need it. Let's also get that back just so that exists. Cool. And then we get our stuff here. So basically, this stuff isn't needed in Bicep. You can also see this is much longer than this. And there's a lot of extra stuff going on in the ARM template. Here, it's all parameterized for us, and we can just start creating it. So let's actually do that. And then we'll go really off the rails and try to get this on to Git. I don't know how that's going to work. But ideally, what I'd like to do is we do have like another 50 minutes-ish. I would like to be able to actually have a Bicep file defined in my code that we can commit to GitHub and have it automatically create these resources for us. So we create pull requests that will change our infrastructure. That's what I'd like to create. We'll see if we get that far. I think that the GitHub Actions integration might be a little bit weird, but we'll see what happens. So let's actually create this though, because this job should be done. Cool. All right, so that's all gone. We removed our thing. So let's actually do this other one, 201. And let's do this. I'm pretty sure, at least for most of what I'm doing, incremental mode is what I actually want. We're just experimenting with the complete mode. So let's do service bus, create. And what else is in there? HQ. Again, there's a ton of different examples in the GitHub for Bicep. So this is literally just exploring the Bicep repo and just pulling those examples right from that. There's also nice things on Microsoft Docs if you want to pull those. All of it's kind of pretty well defined, and a lot of the help that we're getting is coming from that Bicep extension. So we have service bus create queue main.bicep. What does this do? It should ask us for two parameters because we don't have those defined. So it's going to ask us for the namespace name, Sam's test service bus. Sure. And our queue name, Sam's test queue. Because I guess we're just Naming things, again, it's a test. We're just experimenting. These are all going to go away. So we don't need to spend too much time on getting a good name or doing something we're going to remember or want to keep using, because it's gone away. We're just going to be throwing a lot of this stuff out afterwards. So we're doing this, creating our infrastructure. This should create our queue for us and get us some cool stuff. So let's go and see what we created. It might take a bit to show up here, but we can refresh this and it's already there. So this is still being created, so it's going to give us some errors. But it's in the process of sort of scaling this up for us and giving us a service bus that we can actually use, which is exactly what we need for our actual function that we've been developing this entire time. I don't know if I've even talked about too much about what we've actually been creating this entire project. If you're new, this is part of a longer series that we've been running that has been walking through creating an application from scratch using these longer format streams to kind of walk through the process of building something from nothing. So we've been learning .NET 6 and doing a bunch of different things we can explore there. Now we're doing some cool stuff with this and creating all of that. While this is working, that's not where it was. For whatever reason, I use two different terminals. My workflow is weird. But there we go. We get two different things. We get our queue and everything else. There's no outputs in this, but we just created a service bus with a queue. So let's go and take a look at this. And we should be able to see one queue created here. So we've just magicked up a new service bus queue and just by working with this, which is pretty cool. This is, for me, is one of the coolest things because it means we just pointed this at a resource group and said, go and create this with this name and this thing. This is cool because, like, if you want each developer on your team to have their own test service bus environment, or you want a production and a staging and a development environment, or however you set up that workflow, this gives you a way to automate each of those environments sequentially. So you can actually work in any of those environments using a fairly similar thing. You can just parameterize it, define it, and hopefully reuse most of it. And that way you don't have like a staging environment that doesn't actually look anything like your production environment, which is really easy to do. Most of the early staging environments that I was creating were just things that I was manually configuring, which is great. It works. But then you start actually trying to use it and it doesn't continue to work. Hopefully this does, because if we were using the same configuration file, what would end up happening is any changes that were made to your production service would automatically influence the staging one because they'd be in sync. They'd be using the same definition, the same declared state. Potentially with some different configurations. You might use like lower SKUs or smaller resources or something like that in your other environments, but you can kind of tweak those with parameters. You don't need to like completely redefine your environments when you want a new one, which also means like you can just move things really quickly. Anyway, there's our queue. It's created and it works, which is pretty neat. So let's go and take a look at this and what actually happened. So we created this standard scoped namespace, and then we created a queue with a bunch of these parameters, maximum size, required duplication, required sessions, and a bunch of the other information. I don't know if we need all of this. I'm curious what happens if I do this. I would imagine it would just grab all the defaults, right? And so we can kind of reduce this to more or less the minimum size that we need it to be. So there we go. Let's run this and just see what happens. So we're just going to run this with what if. Again, if you want to see what the changes are going to look like without actually committing your thing, what if is going to give you a way to do that. It's going to basically mock run your code and give you the diff of what that would look like. So we called it Sam's test service bus and Sam's test queue. Sam's test service bus and Sam's test queue. And let's see what we get. So hopefully this will actually show us we get some defaults. I don't know if they'll make any sense necessarily, but that's what I'm hoping we see. And it looks like all the properties just get deleted. I don't know what this would do. So all these properties in the ARM template would just get removed. So I imagine it would just rely on whatever the defaults are for that version of Service Bus. I don't know what those are. To be completely honest, no idea. So that would do something. Ideally, you probably want some of these things configured. You want to be able to say what the state should be. And so I don't know if this makes a lot of sense. Let's undo it. But that's an option that you have. You can kind of walk through these things and update them and change them and do all sorts of cool, fun things with them. We do have an option here of different ways we can go, because we've kind of got this to the point where we can create resources. We can create a service bus through Bicep. That's the thing, this one. Or we could explore a different tool for this and kind of go a different route and see, does this make sense or do we want to do something different? The other tool I'm thinking of is Pulumi, which lets you do similar stuff, similar infrastructure as code framework, but it uses C#. So instead of writing Bicep, which is its own language, you could code in your own language. So those are sort of like the paths that we can choose. Whenever you're developing something, there's always lots of choices. And same thing here. We could go either way. We'll see. But if anybody would really like to see one of those or the other, you can call it out like now, and we can kind of steer in that direction. For now, I'm intending to go the full CI route with Bicep, but we can change that if we want to. So what we want now is something that actually works with our application. We don't have that. So what I'm going to do is grab all of this and actually go and look at what we've defined in our application. So I don't know if I've talked too much about what this app actually does yet, because we've kind of been focusing on other things, but we're going to create a main.bicep. That's going to move. What this is an application to transform meshes. So given a transformation that you would like to see happen and a mesh that you would like to see it happen on, you can provide parameters onto a queue. It will pull it off that queue, perform the transformation, and put it back onto a different queue. So we need something that creates two queues and can support that basic infrastructure. It looks like this. Cool. So this is using some Mermaid charts, but we have two queues, one on either side. And then in the middle, we have our mesh transformation that we're actually working on. So we have an Azure function that is actually doing the input and output for this transformation. And then some mesh library that has some new C# features and some tests and things to actually do the math part. And so that's all done. All of that works. We're kind of in the final stages. What we're working on today is this exploration, trying to figure out how we can codify and make sure that give a concrete definition for our infrastructure. Then tomorrow, we're going to be taking a look at finally getting everything to like MVP release state. We've built this over about 10 hours total. So obviously there are gaps sort of intended. There's technical debt. There's things that could be better. Maybe there's architectural decisions that maybe aren't exactly what they should be. That's kind of the point. because like we're doing this really quick, but like applications change and shift. And so even if your architectural designs do make perfect sense, they won't in a few years' time. And so this gives us a way to, in the future, sort of come back and address some of the technical debt, introduce some of the new things that are emerging and things like that. But that's sort of what we're doing. And so this entire infrastructure as code exploration has been setting up this queue. That's basically what we've been exploring, is a way to declaratively create that queue and this queue, and potentially the Azure function in between. So theoretically, all of it could be handled by this. So I've created a main.bicep. We probably don't want that in the root directory, so let's put it somewhere else. We'll call it, names are hard, infrastructure, sure. And we'll just drag and drop that into there, because we haven't done any commits, so we won't lose any history if we do that. And then we just get this thing, which is the defined service bus stuff. So that should create that for us. Now we can save that. What we're trying to do is create service buses. So I'm going to continue working with that test namespace for now. And then once we're more confident in this solution, then we can use the actual infrastructure definition we're looking at. Just so we don't like accidentally drop prod. That from what we explored, that shouldn't be possible, or it shouldn't happen directly. But ideally, we want to kind of avoid that. So we're going to take some steps to make that happen. But this gives us the same service bus definition that we had previously. We get all the same settings, all of that. We just need to actually define this thing. So we have resource groups, we have our locations. Let's actually do something. So what's the best way to do this? I think what we want is some new push infrastructure, push info.yaml. I haven't written this before using Bicep, so I don't know what I'm doing. We'll see. But that's sort of what we're going to be playing with. We have push infra. We want to basically take this exact same definition, which what this is doing is running our tests against our push domain, or running our .NET tests when you push into the main branch, just to make sure everything is green. We also are going to want, when there's a change, so we're going to run this path, I think it's paths. That's the wrong place. So we'll push to paths, and this is a list of different paths to work with, infrastructure. But when there is a push to this infrastructure directory, we're going to run this code. Expected string. Okay, this is not a list. Today I learned. Is that what? Okay, now it's expecting an array. I'm confused, but that's okay. Not the first time. All right. So we get our infrastructure. That should be the name of the directory that we want to monitor. And that will prevent this from running other times. So if we just merge in code, that shouldn't in fact impact our infrastructure definitions. That's not really what this is for. So just infrastructure changes, just changes to this bicep file. And then I need to go and do some searches and figure out how to do this. One of the convenient things with this, I guess, is if you search for arm to bicep, for example, like I did earlier, you do not get Azure related things. You get workout related things that are going to tell you how to work out at a gym or something. So when you're searching for these things, probably include Azure, and it will help refine your search a lot. Just because otherwise they're both arm muscle group things, and you're just going to get workouts. Especially arm to bicep is yeah. I didn't get any useful results that way. So something to keep in mind when you're searching this stuff. But let's explore this. I think going back to the docs, because why not? There should be something here. If I'm remembering, bicep with GitHub Actions. Perfect. It's already documented here. So we can actually just go to the docs for bicep and get some more information about this. So I'm just going to try to rely on what's defined here and work from that. Create an account, create a group. We already have one. And then we create a service service principal. That's the name. I can never remember acronyms. Anyway, we create a service principal and then define its scopes. Okay, so we need a subscription ID for that. And give it SDK auth, so that'll allow it to do fun auth things, and then upload that into GitHub Secrets. Looks like it's just using Azure credentials. Some will do different things. Oh, okay. And then an Azure subscription and Azure resource group. So the Azure resource group is just, this probably doesn't need to be a secret. I don't know if I should say that. But this is going to define what resource group you want to deploy this thing into. And then the subscription ID is the third secret. Again, when you add secrets to GitHub Actions, they don't get printed out when you run your action. They do get masked out for you. So there's that. And then we have our bicep file. Looks like this example is just deploying a storage account. We're just going to deploy our other thing. It looks like they also have a parameter here. So we should be able to, we're using basically the same scenario, just with slightly different use cases. So we're just going to grab this. This is on push. We're going to be a little bit more restrictive and do it on push to that infrastructure directory. And add this, not there. That's not the right thing. Let's just get rid of that. There we go. And we can create this. And we have our push infra thing. And so we're just going to overwrite these jobs with the ones from that template. So walking through this again, if you're unfamiliar with GitHub Actions, what's going on here? We have a set of jobs. The different jobs you define will run in parallel. But typically your GitHub action is just going to have one job. You can have multiple, it's totally fine. But most often you're going to see one job per file. It just seems to be the way it works out because concurrency can get weird. And usually steps are fine. So those jobs have a name. In this case, it's build and deploy. So what this is doing is creating a job called build and deploy, which is going to run this specific job on an Ubuntu server. You can go and check out on GitHub what is actually on that Ubuntu server. And then it's going to check out the code from your repository. It's going to log into Azure using those Azure credentials that we have to create using the secret there. And then it looks like there is a arm deploy function. So if you're unfamiliar again, uses is defining a specific GitHub action that you want to use. And these are just things. So if we want to learn more about what this Azure arm deploy thing is, we can just go to GitHub and do github.com/that. And we'll get the name of the thing. So this is the action that is actually doing all of that. And so you want more information about that? That's where it is. So we get all of that, and that's not the right thing. There we go. And then this is just to point it with the subscription ID and a resource group. So subscription ID, I have two on this account. And then the resource group is used as a way to define the resource group. So you actually know where it's going inside of that subscription, because your subscriptions can have different resource groups. Then you just give it the name of the template, which in our case is not main.bicep. It is infrastructure/main.bicep. With a parameter, we need to provide those. So parameters, let's do that. Let's take a quick look at what this is. It looks like it accepts a parameters JSON. That could be useful. We might want that. Let's actually figure out how to use those. So there's a parameters JSON, which actually defines the parameters for you. That's probably what we actually want, because it means we can actually define different parameters for different environments. Like I was talking about production and staging. This will give you a way to, if I'm understanding it correctly, define what those are so you can just switch between them really quickly. Storage account types. Otherwise, it looks like it's just key value pairs in here. Cool. All right. Let's actually do the thing. Where do I define an ARM parameters JSON? So Azure Resource Manager parameters JSON. And this parameters JSON is the same for ARM and for Bicep. They're intercompatible. So you can use one with the other. Create parameter file. Cool. That's what we want. So we get this. It looks like it's just a slightly more complicated key value pair. So we can grab this. If you're unfamiliar with what's going on here, this schema is defining what the format of this JSON file is for you. So it actually knows how to interpret this. So let's do that. Create our infrastructure, new, and let's just call this test environment.json. That will just give us a nice parameter thing. And then we need two things, I believe. We need service bus namespace name and the queue name. We should just be able to plop those in there and work from there. So we get this and this. The namespace name is, we should, again, this is a test, so we can actually probably mess around a little bit with this. Sam's service bus namespace. Sure. And Sam's service, let's spell it right. Service. I'm going to pick every vowel that isn't an I. Service bus. That's cute. Cool. And so this should be all of the parameters we need. So if we go and look back at the docs for this, where was it? Bicep. Deploy bicep files. There we go. So what's going on here is it's providing a parameters. We should just be able to provide the file. That's what I gathered from this here. If you just give it a path to the file, it seems like it works. So we're going to try that. See what happens. It might explode. That's cool. So let's try and see. So I can open the right thing. Here we go. Push our infra. Our parameters, none of that needs to be there. Instead, we're going to do /infrastructure slash what do we call it? Test environment.json. And so if I'm understanding everything correctly, that means we're going to pull in all of our parameters, actually use that, run this, create all of the cool stuff, and get something back out. So now we just need to actually define our secrets and push this. Should be good. I'm also going to do some bad things. Let's go to our main branch, pull this down. Got a little out of sync there, but it should be fine. You don't have any conflicts, so it's all good. As on a different branch, you can switch branches if you haven't committed. It's fine. You just might get into conflicts, so keep that in mind. But we're back on main. Let's go and create a new branch. Let's do infra in CI, I guess. We'll run that. And I'm actually going to, how do I want to do this? So we have all this. Let's do on pull request as well. And we're not actually going to leave this in, but what this is going to do is mean that when we open this pull request, this job will run. So it means we'll run this job to actually deploy everything when all of this happens. And so that should be sort of what we want. It gives us a way to test this without merging it into production. We also probably might want like a what if thing, which I wonder, is that even an option here? Deployment names, regions, scope. I don't see it, but it looks like there's additional arguments, so you might be able to provide that there. And that might give you that what if, and then you could write that out into like a comment on the PR, for example. We might explore that later if that's something that people are interested in. But we're already kind of into the weird technical part that it gets annoying and complicated. So let's do this. All of that is good. Fail on standard error, that's cool. Resource group. All right, we need to define these things. So let's actually go and do that. The stuff we need is defined inside of this entire tutorial. So we kind of skipped over it previously, but that's cool. Okay, so this is just saying parameter files. Already covered that. Already went on that tangent. Cool. So up here, before all the stuff that we skipped over, is the information about secrets. We need to go and create that. Again, this is a demo. This is intended to like help you all learn this stuff, and me as well. Don't share your secrets, please. It is bad. It means people are going to be able to do all sorts of crazy things that you do not want them to do. So do not share your secrets. We're going to be sharing secrets here. Just showing my process of doing this. I'm going to be creating these secrets on screen. You should not do that in almost all circumstances. And anytime you do this, you should re-roll those credentials as soon as possible, because this is not good. What this is going to do is show you a thing that can actually create resources in my cluster or in my Azure resources. That's probably not good for anybody to be able to grab those credentials and do that. So we're going to avoid that and instead remove this after this demo is done in 30 minutes. So that's what's going to happen here. Just want to call that out. GitHub does warn you sometimes if it detects things that look like secrets in your code. That's one of the more common places they end up in. If you're working with an API and you end up with an API key in your code, that's not where that goes. Probably some other thing, key vault or an environment variable, or some way to keep it out of your code so it's not in your source control. And if you're publishing to GitHub, accessible to anybody. So that's that tangent out of the way. Let's create these things. So we need to do this. I need a subscription ID. So let me go and find that and a resource group. But this is the code we're going to be running. So I'm going to grab this, put this over there just so I can have a reference. Multiple screens help a lot of the times with some of these things, or minimizing things. But anyway, we're going to paste that over there. And I need my subscription ID and my resource group. Both of those we can get from here. There we go. Dev test. Let's grab that. That probably doesn't need to exist. Let's go and grab this thing. Dev test. That's the name of our resource group. So I'm just going to throw that in here. SDK auth. Our resource group. I'm just going to paste it in. And then what else are we calling it? My app. That should be okay for like a quick test. And then I need a subscription ID. So let me go and quickly grab that. So I'm just going to pull this over here, just because that is something that I'm not going to reroll. But it shouldn't matter too much if you have that. Anyway, copy to clipboard. I think that should be good. Let's do this and swap this in. All right. That's not how you do that. Okay. Cool. I need to go and figure out how to get my subscription ID because I have forgotten. There we go. I do have an extension that's hiding it, which is part of the reason why this is complicated. But there we go. We have it. Let's go and paste this in, just so everybody is on the same page. There we go. We're going to call this something other than my app. We're going to call this our infra automation user something. This is probably fine. So we'll create this. There's 3 secrets that we need. That's going to go and run and get us some stuff. There we go. So we have that, and now we need to go and create these 3 secrets for us. So we have not that, click the wrong thing. There we go. Cool. So all of this, let's go to, I just closed it. There we go. GitHub. So we can go to our GitHub, which is under /matrix mesh. GitHub secrets are configured in your settings. So we go here. And if I go to secrets, we have a few. So let's go and create those. So 3 new repository secrets are going to be created here. And we're going to be basing them off of this thing. So copy the JSON object. So we need to copy over 4 things rather, from this set. We need the client ID, client secret, subscription ID and tenant ID, which in this case are the first 4 of this big list. So that's the 4 we're going to copy. And so we should be good there. Let's just call that Azure credentials, just to match the example credentials. With that, we need to make sure we're ending our JSON objects. So remove the comma and add a bracket, and there we go. These are going to go away. You shouldn't. If you need to re-access your secrets, just regenerate them. That shouldn't be a hard process to do that. Because if for whatever reason you leak your secrets, you want to be able to re-roll them as fast as possible, just so you can get that vulnerability out as fast as possible. So Azure credentials, let's add that secret. And now that everybody knows how to create resources in my environment, let's go add 2 more things. So new secret here. The other one is the Azure resource group. And these are actually both coming from that command that we ran. So both of these are going to be the resource group, which is our dev test variable. So dev test, add secret. And then the other one is going to be this subscription ID. So if we copy that, we can do whatever it's called. We don't need to go and look at the tutorial. We can actually just pull that straight from here. Azure subscription. So these are the secrets we're using. If you're curious, Azure subscription. Subscription. There we go. And so that creates that. So that's our subscription ID, our resource group, and credentials to actually access our repository. And now I'm going to go and delete all of the resources in our thing. So this is going to go away. Not like that. There we go. Go into our service bus and delete it. So we're just going to go Sam's. Type in the namespace name. What was the namespace name? Sam's test service bus. There we go. And so that will delete the queue as well as the service bus. So we can get rid of those. That should reset this back. We could have done that using the complete thing like we used previously to roll everything back. But here we're just using this. So that's going to go away, and we're going to create a new one. So let's see that actually work. So we go in here, look at all of this. We have everything configured, so it's going to log us into Azure, and then it's going to run our deployment. And this is going to take a push and commit it to whatever. Probably don't want this exact configuration because it's based off of pushes or pull requests that get opened. So anytime somebody's like, hey, is the change good? We deploy the new thing to wherever we said. Probably don't want that. You might if you want like some test environment for people to actually be able to like poke at it. But consider the use when you're doing that. It depends on what you need it for. So that's that. That will define everything we need. Validate main. I don't think that's what this needs to be. Deploy infrastructure. So this name is what the name of the actual GitHub action is going to be. Just so we have something to reference. Build and deploy. It's going to build and deploy our infrastructure. Cool. That should be everything. So if I've done all of this correctly, and I think I have, we should be able to commit all 3 of these things. So we have our parameters here, which are saying the name of the namespace and queue that we're going to deploy. We also have this, which is going to define what resources we want to exist. And we have our CI job that it's actually going to run that stuff to deploy the thing. So that should be everything we need. So we can just call this automate infrastructure. Cool. And so with that, hopefully, we have some automation going. Now I just need to publish this for that to work. I'm going to double check that it is gone. It should be. So let's just refresh this quick. And it's gone. All right, cool. Perfect. So now we can push this, and hopefully, once I've pushed this, it will create the new branch out on GitHub. We can then open the pull request and watch the job actually go and do everything that I was just doing on CLI, but automatically. And then we can pull out the little hacky thing we did to make it run the code that we wanted. So we want this. This is the project we were looking at. So compare and create pull request. There we go. Automate infrastructure. Sounds great. There's all of our changes. And we can create this pull request into our project. It should kick off a automate infrastructure job. Build and deploy right there. So we have our 2 test jobs, which are still running because those are things we've done previously. But now we also have something to deploy our infrastructure, which should be creating a new Azure resource for us. The one thing that could fail here is like our credentials are incorrect, or our secrets are misconfigured in some way. But it looks like we should be good. So this is just going to log us into Azure and do all of that normal stuff, and then go from there. This would be a great time for questions because this might take a bit, because it is creating a service bus for us. But there we go. So if there's any questions, let me know. Otherwise, we only have 1 day left of this project, which is tomorrow. We're going to be kind of wrapping everything up. We have the application working, but what we do need to add is some way to like finish all of those little undone things to kind of ship it. So we're going to be focusing a lot on like monitoring. How do I know that this thing is actually working? Potentially tracking over time, like the messages you're processing. So there's some dashboards there, so you can actually see, are we processing messages or are we not? And things like that. Also looking potentially like tracking errors and things like that. So we can identify and address issues that might come up in our deployed environments that we don't see in dev. Things like that. So there's probably more there than we can cover in 2 hours. But that's sort of what we're going to be poking at and trying to add as much of that as we can, just so we have a little bit more confidence. Looks like that worked. So that's cool. If I sound shocked, things never work when I try them the first time. So this is cool. But there we go. Our service bus namespace, which is coming from this. Here. Our SAM service bus namespace. Cool. We just created something. Let's go and rename the queue. Because why not? We're doing things. So service bus queue. That ran when we created the pull request. When we update this, we should get a new one. So let's just do .2. And so this is going to change the name of the queue. So we should see some new stuff happen here. Change queue name. Admittedly, my queue names are not very inventive, but it should be good enough to kind of get this demo going. So we run that. We sync these changes. That pushes them up. And that will actually allow us to change things. Hello again, Deflux. Welcome. And yes, it is. Hi. We're doing infrastructure as code. So we're building all sorts of fun stuff. But yeah, we're actually almost wrapping up. So I can't cover it all, but if you want, there is going to be a whole recap of this on YouTube in a few days. So you can go and watch through. So yeah. That's that. We are actually doing some other experimentation with how we can do more Twitch integration, just to kind of build some cool things with the community and kind of get everybody else involved in what we're doing with the reactors here. Hopefully to make that really fun for everybody. So yeah, we'll see. But yeah, Twitch definitely. Anyway, this is something we're exploring, so we'll see if it works. But I'm enjoying it, and hopefully you all are too. So we've created that, we've pushed that. Hopefully, if I've done this correctly, we no longer have a queue named. We have 2 queues now. Okay, that's interesting. This is probably related to we're doing incremental changes, right? So resources that just disappear from our definition are gone, or are not gone. They're just there still. Hit things. But now we have 2 queues because we redefined this other one. And so if we keep renaming this, we're going to keep getting more and more queues. That might not be what we want. Let's see if there's a way to drop that. What would we even search for? I don't know. This is something that is hard. That I'm not entirely sure what the best way is. Like, so there's no state tracked, right? And so because of that, how do you know what's not there anymore? Deploy with bicep, cool. Deploy child and extensions. We probably want something outside of those lists. Deploy commands. Let's look at the CLI. Deployment scopes, tenants, lots here that I do not know yet. But there we go. Inline strings, cool. Templates. Some of the stuff we worked with, some of it we haven't, and we have 15 minutes left of my time, so we probably can't get into all of it. But hopefully this is cool. Like, we have infrastructure that we can just deploy automatically by changing some configuration and deploying things. To finish this, so I don't get too distracted, let's fix this a little bit. First, let's remove that 2. That doesn't need to be there. Second, let's update this so we aren't doing this on pull requests. We're just doing this on changes to our infrastructure directory. I don't know why that yells at me that it's not a string. There must be some weird white space thing. YAML's weird. If you're unfamiliar, YAML's weird. Especially YAML 1.1 gets odd. Things get interpreted in ways that you may not expect. So just things to keep in mind. But there we go. We have our infrastructure. Let's push this. This means we're not going to run this again when I push this. Because it's just on the pull request. We'd actually need to merge our changes onto the main branch, and then we should see it run again. So let's do that. Fix PR comments. There are no PR comments, but I'm going to say that. There we go. And this will get squashed out anyway, because we are automatically squashing pull requests. What that means is that if you have multiple commits in a pull request, like fix, try again, those kind of commits, that's really unhelpful and actually makes your code really complicated to understand. One of the useful things that you get out of source control is a commit history. So if you look at like my commit history for this project, I don't know if I've done great work with keeping it all sorted, but you can actually see things are based off of pull request. So there's one change per pull request. And you can see in this one, we implemented mesh math. In this one, we added an Azure function. Things like that are useful to know. And if you have like these 3 changes here, it makes things really complicated, because if you actually want the automate infrastructure change, what was required in the code to be changed in order to automate our infrastructure, you can't just look at that. You have to look at 3 different places, because we have it spanning 3 different things. By squashing everything into a single commit that is kind of encapsulating all of those changes that were required and all of that work, it makes it really easy for anybody else who wants to go back and kind of see what happened and why. Especially if you're like trying to debug something and you're searching back through code, and it's and you find one commit that like fixes X, whatever X is. When you fix that, great. But if the change is spanning 10 different commits, people who are looking at fix X are going to see like 3 files changed, and maybe you needed to change like 20. And so it can obfuscate that. So squashing is useful in that case. You might see it in a lot of projects to squash and merge. GitHub does it automatically. You can also do it on your own side if you want to reorganize commits in your own way. Git rebase and stuff will give you ways to do that. but that's way outside of what we wanted to talk about here. So we're just going to do that and look at this pull request. There we go. Fix PR comments. Cool. So file changes look like this. Scroll through those really fast. This is public. Unchanged files with check annotations. Okay. It looks like we have some linter errors. That's cool. So those are just coming out of our test. Oh, that's neat. Okay, that's super cool. I didn't know that happened. That's awesome. Okay, that's something cool. But I don't have time to go into it right now. Anyway, here's our infrastructure. Here's our change. Let's merge it and get everything kind of working. And we should actually see the job run one more time. So just to kind of show that things are still working, we're going to go and delete our namespace because I guess that's just the best way I can think to do it. So we're going to do Sam's service bus namespace. There we go. All right, there we go. Service bus namespace. Okay, and delete that. That will drop all this, and then when we merge, we should get all of our resources back. And then any other additional merges into that infrastructure file are actually going to get automatically deployed for us. And so we should just be able to constantly maintain and update our infrastructure over time. Obviously, one of the useful things that would happen is like Azure functions might be useful to have a reference to. I believe I closed it, so never mind. But I believe there's actually an example of that. So we will merge this and we should be good. Again, squash and merge, you can change this. Some project maintainers in open source may not allow you to do all three of these options. But my default is usually to squash and merge. So we can do this. The three changes end up getting bullet pointed here. If there was additional information in those changes, it would end up in between. But adds infrastructure automation with ISAP. Cool. Yeah, that's not how you spell that. It doesn't. It's so bad that it doesn't even know. What did I type? Okay. Yeah. Okay. We got there in the end. I don't know what's going on there. My spelling's bad. But yeah, there we go. There's our change. We can squash and merge this, and we should see some new things going. I'm going to delete the branch just so it's not there. Speaking of that, one cool thing, if you're working in a project like this and you have working branches, one of the things you might end up with is a lot of branches. You might end up with just a huge number of branches just accumulating over time. We already have a bunch. So we can go here and pull down all the new things. And I think it's called git. I want to say. That's not what I wanted. Well, let's go and find out how to do that. Git prune old branches. And you can look at a remote repository like your main project's repo and clean up or prune all of the additional things that might be there. It's a pretty handy way to kind of keep things. Prune branches, is that the name of it? Maybe it's a command. I don't remember. There's something you can run. I don't have it. Maybe that's it. Git remote prune origin. I think that might be it. Remote prune origin. So in this case, origin would be the remote repository. So let's go and grab that. Sure. Git prune. This might be something that I'm misremembering, so I'm trying to think about it really quick. Git prune. Yeah. Okay. Let's try it. So if we do this, git prune remote, which is saying, look at this remote repository. And origin is the origin remote repository. That is when you clone it, that's typically the name of the thing. If you are working against a fork, for example, you may have an upstream and an origin, or whatever names you're choosing to use. That's kind of up to you. In this case, git prune remote origin. We're just going to run that, not a git repository. That's correct. It's not. So if we go into matrix mesh, there we go. All right. This is a silly tangent, but it does work. I swear. We can even have this automatically run on pushes, for example, with a quick hook. Way off topic though. So let's quickly just make sure that I actually deployed everything correctly. We have our service bus. We do not. What happened? Oh no, that isn't correct. So this ran. 2 jobs completed. It didn't run. Well, that's not good. So I may have screwed something up. This infrastructure path may not be correct. All right, we have 4 minutes left. Let's do that really quick. So fix GitHub infra. Sure. So we're going to fix this so that this is actually correctly pushing things. Infrastructure. I am having trouble reading that, so we're gonna do this instead. And cd info. There we go. We're just gonna grab that and paste it there. Linux file system. So flip over the slash from Windows, and we get this. We will see if that works. Fix GitHub infrastructure. Sure. Some weird name. Anyway, let's push this. This might get a little bit awkward. I don't know if there's a better way to test this. What I should have done is tested this beforehand, but I didn't because I was thinking of different things. So we're gonna run this quickly and try to get this fix in. We'll see. This might be a mistake. But let's fix action action path. Sure. We'll publish that. That will end up there. And then we should, hopefully, I have done this correctly, see a new pull request. Let's open that. Create. And we're just going to quickly merge this right away because confirm squash and merge. Sure. Do some questionable things. We're on a little bit of a time scale, so we're gonna kind of run through this quick. But that will hopefully run this. We should now see an action get kicked off. If I have done this correctly. So deploy infrastructure. Does not run. Okay. This will be something that I think we can fix tomorrow. I'm overlooking something, and I'm not entirely sure what. But the name of this is just not working, not fixing what it needs to. I do want it to be somewhat limited because constantly running this thing to update our infrastructure seems like a lot of extra work that we don't need. We're not making changes to that. It also means if we want to tie this into like pull requests, we don't need to show you the infrastructure diff if there are no infrastructure diffs. That's just a lot of extra noise that you don't need. And it might just get confusing. So we're going to avoid that, hopefully. But it may have been a little bit over ambitious in trying to limit that. But hopefully this is useful. We are somewhat out of time, so I'm going to kind of wrap up quick. This is Bicep. So we kind of walk through Bicep. There's a bunch of cool things. It's on GitHub, so you can go and check that out. Or there's doc links in the chat. Other things, there's other options. So Terraform, Pulumi, even, whatever you want. There's lots of cool options here in this space. So it's a really fun way to kind of automate this stuff and play around with it. But that is everything for me, so I will leave it here. So thanks everybody for watching, and hopefully this was interesting. So thanks.
Thank you so much, Sam. Thank you so much for this very nice session. Everyone, please, if you have, please note that your feedback is really important for us. So if you have time, I put a link in the chat. Just use the code 14754 so you can give us your feedback. And also you can check out the rest of the sessions in this series. I also dropped the link in the chat. Other than that, thank you so much all for joining. Again, Sam, thanks a lot.